welcome to today's lecture. Today we will be focusing on resolution and what you need to know to get the best printed photo. In this lecture you will learn to identify LPI and PPI as it relates to printing, identify line screens, understand how a halftone dot is created and how it relates to resolution, understand how to process originals for optimum quality on the press, and a few things that we'll need for today's assignment. What does it mean? In graphics terminology, image resolution is generally stated in one of three ways: lines per inch for commercial printing, dots per inch for overall printing, and pixels per inch for actual image resolution. Lines or dots per inch. LPI/DPI is a measure of how close together the lines in a halftone grid are. So you kind of notice we're expanding from last week's lecture. LPI and DPI is the number of halftone dots that will fit in 1 linear inch. These dots are used in the printing world to reproduce a continuous tone image. Here is a halftone square. So as we discussed last week, as you enlarge the image, you will see that in the darker areas, the black dots are larger, and then the lighter shaded areas, the black dots are much smaller. Still printing on the white paper to allow the white to show through to help with that tonal image. And even closer, it's even more obvious how the halftone dots create an image. Lines per inch. These dots are what we call printing dots. LPI is also known as line screen or line frequency. LPI indicates the number of rows and columns of dots in a linear inch. For example, a job printed at 133 LPI will have 133 dots across and down in 1 inch of the image. So 133 times 133 is 17,689 dots, all in 1 square inch. So for printing, we try to have a 300 LPI or DPI image. So it's 300 dots across and 300 dots down for the best resolution and the highest quality. Lines per inch. Examples of offset printing standards. So to kind of help save money, as we've talked about last week, that each plate for a color is on its own, so each color has its own plate. You can imagine the more dots there are, the more precise it has to be, and the more expensive that plate becomes. So the print industry has found loopholes to kind of help lower the cost. So a newspaper goes out weekly, flyer goes out weekly. It doesn't need to be the best quality print. So having it 85 to 100 LPI means that the plates will be cheaper, it'll print a little bit faster. With less dots, it means that there's less likely for the image to be kind of smudged, so it makes it for a faster, cheaper product. And then if you have stationery, business cards, some book publishing, all things that are usually one-time use, you want them to be definitely professional. So the 120 to 133 LPI kind of has that technique. And glossy images for annual reports and things like that, 150 to 200, you can get away with. So it's all about what you need to produce. If you were to be printing an image for a wall, the higher the LPI, the more detail, the better the quality. Pixels per inch. PPI is a similar measurement to LPI or DPI. Pixels per inch is the measure of the quality of an image. The higher the PPI, the higher the print quality. Pixels per inch directly relate to the actual dimensions of the file. PPI describes the number of square pixels that show up in an inch on a digital screen. So as we kind of furthermore discussed from last week, Your computer screen is rated for about 72 pixels per inch. So that's a big difference. If you've downloaded or saved an image off of Google, you tried to put it in your school presentation, a PowerPoint, you stretched it, and it became really blurry and hard to read. That is because it's just not designed to be stretched. To save graphics time and to save your computer from working overtime, they lower the resolution of the image to kind of lower the memory that it takes for your computer to work. Pixels per inch. Keep the resolution relative to the final image size and output device. When reducing an image, the existing information is packed into a smaller space. Therefore, your image resolution will increase. When enlarging an image, the existing information is expanded into a larger space. Therefore, your image resolution decreases. So if you have a small resolution and you try to enlarge it, it'll get blurry. However, if you have a large resolution and you decrease it, that just means your resolution is increasing because it is getting more dots in a smaller space. So this is what we'll be working with today in Photoshop. So this is our image size. So if we go into Photoshop with our image, we have our image size. It tells you what the image. So this one is 83 centimeters across by 83 centimeters around, and it's at a resolution of 72. So that's pretty much any picture you take on your cell phone also goes to that 72. They've worked on making the resolution better with the phones by taking larger pictures to kind of help with this situation. So what's important to note here is our resolution is not relative to our height and width. So it means, like we've discussed before, the link is closed here, so if I change the width, it will automatically adjust the height. However, the resolution is on its own. To make sure that you're doing this properly, you want the resolution to be relative to the width and height. So if you adjust the width and height, the resolution changes. So from our previous box to this one, I've updated the resolution to 300 for print, and you can see the size of the overall image decreased to 20 centimeters by 20 centimeters. So this is something you should take into account whenever printing an image or putting it into your InDesign file. LPI and PPI for our print shop. So not so relevant this year. Maybe if things change, we can try and print something next semester. So for our printer, the Roland and the Epson. So the Roland is our wide format printer that does banners. It does canvas prints, t-shirts, vinyl wraps, whatever it may be, needs to be 300 pixels per inch. And the Epsons are our standard photo printers, so they have to be that best quality. The Ricoh is 150 pixels per inch because it is just your standard photocopier. So nothing we print on the Ricoh is going to be overly complicated. It doesn't need to be the best quality. It's probably a single use. So lower the quality, it'll be okay. We have an offset Heidelberg out back, and you can get away with 150 down by 150 across for 300 LPI. Now let's head back to our chat and discuss this and see if we have any questions. Have a great day.